Hello JEE aspirants. From our channel JEE Math Tricks, there is one more useful and benefitable video I am making for all IIT JEE mains and advanced aspirants. It is a mind mapping of the chapter 3-dimensional geometry. The chapter is a small chapter with many concepts, but sure questions will come in mains and advance. And this chapter is such a chapter, once you understand the concepts, that whatever that question they give, you can answer easily. So scoring chapter, this one. So let's look into that mind mapping. What all things we have to remember the moment we thought of a three-dimensional geometry is that we need to talk about coordinate system. What are the coordinate system? And then we do discuss about a direction, ratios and cosines. And then we will be talking about planes, then lines, and then we do talk about a distance between point and line, point and plane, line and line, line and plane. So these things we discuss. Finally, there are some shortcuts or problem solving techniques and PYQs. This is the what a student must think of that learning that chapter 3-dimensional geometry. Now in this video, let's look into one by one points. Okay, so in total only 6 points, if you remember, it's enough for a 3-dimensional geometry. Let's look into the coordinate system. And here we do take reference of 3 mutually perpendicular lines, x-axis, y-axis and z-axis. And these 3 mutually perpendicular lines divide the space into 8 equal parts. We call them octanes. And any point in the space x, y, z, any point in the space P can be expressed as a ordered triplet x, y, z. What is this x, y, z represents? This x is called x coordinate, y coordinate, z coordinate. If you draw perpendicular from point to x-axis, that will cut that x-axis at x0, 0. Similarly, if you draw perpendicular from point to y-axis, it will cut y-axis at 0, y0. Similarly for z-axis. Now here we do talk about these 3 mutually perpendicular lines divided that space into 8 octanes, we told, right? And these 3 mutually perpendicular lines also constitute 3 planes. One is xy plane, next xz plane, as well as yz plane. And right, okay. Now if you observe carefully here, every point P xyz, if you take the perpendicular distance of that point from xy plane will be mod z, and the perpendicular distance of the point from yz plane, this plane would be mod x, and the perpendicular distance of the point from xz plane is mod y. This point is very important point. So in 2-dimensional geometry, the perpendicular distance of a point x comma y from x-axis is mod y, from y-axis it is mod x, whereas here to the planes, perpendicular distance of the point to the planes will be mod x, mod y, mod z. So every point in the space can be uniquely expressed as an ordered triplet x, y, z. Okay, depending on the octanes, that will be positive, 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 negative, positive, negative, positive, like that, all that 8 possibilities, because every option has 2 choices of plus and minus, a total you will be getting 8 octants. Right. Now coming to a topic, a line in space. What is the angle made by a line in space? Suppose you consider a three-dimensional system, three-dimensional coordinate system, and consider a line in space. The angle between this angle made by this line with x-axis, y-axis, and z-axis would be, even though the line do not intersect x-axis, but still we do define angle between two lines. So what we do, parallel to L, we do take a line passing through origin. The angle made by this line with x-axis, we call it as let us call it as alpha. Angle made by this line with y-axis, let us call it as beta, and the angle made by this line with z-axis, let us call it as gamma. So in two-dimensional geometry, we know that every line can be described by slope and a point. So what do you mean by slope of a line? The inclination, that slope tells about line, the angle made by line with the x-axis is theta, then slope is tan theta. In the same way, so here also we do talk about the inclinations of the line with x-axis, y-axis, and z-axis. So those we call directions. So indirectly we are talking about direction of a line. So a line in space can also be treated as a vector in space. A vector has a line segment. A vector is a directed line segment, whereas a line means unbounded direction. It has a direction but no infinite length. Fine. Now this, if alpha is the angle made by that line with x-axis, y-axis, and z-axis, alpha, beta, gamma, then that cos alpha, cos beta, cos gamma, these three we call it as that order pair L, M, N, where it is cos alpha, cos beta, cos gamma. We call this as a direction cosines. We call them direction cosines. Simply we denote it by DCs. Right. So every line, if a line makes an angle alpha, beta, gamma with the positive direction of x-axis, y-axis, z-axis, alpha, beta, gamma, in the negative direction, then it will be pi minus alpha, pi minus beta, pi minus gamma. So plus minus minus L, minus M, minus N will also be the direction cosines. So every line in space will have two direction cosines, whereas a line in 2D has only one slope. So slope of a line is unique, and the direction cosines of a line in space, you will be having two lines. One is plus cos alpha, cos beta, cos gamma. Another one is minus cos alpha, minus cos beta, minus cos gamma. So this direction cosines will be treated, or it will help us as if that a slope of a line in 2D help us. Next, coming to direction ratios. So here there is a property related to direction cosines, that the sum of the squares L square plus M square plus M square would be 1. Let's see. Suppose you choose a point. If you choose a point in the on the line x, y, z on the line, then if you drop a perpendicular to y-axis, suppose, then this perpendicular, this coordinates of this one will be 0, y, 0, and the cos beta, if you calculate, cos beta equal to adjacent is y by distance of that from origin, that is OP. Similarly, cos alpha will be x by OP. Cos gamma will be z by OP. If you square each of them and add it, cos square alpha plus cos square beta plus cos square gamma would be, here x square plus y square z square by OP square, both are same, so it will be getting 1. So L square plus M square plus N square is always 1. If L, M, N are direction cosines of a line, then L square plus M square plus N square would be 1 always. For example, here suppose you take 1 by 3 1 by root 3 minus 1 by root 3, 1 by root 3. These three can be direction cosines of a line because sum of the squares will be 1. Whereas suppose you take 1 minus 1, 2, this cannot be direction cosine because there is a sum of the squares is not equal to 1. Okay. Then in improvised talking about the purpose of talking about direction cosines is direction of a line. So more convenient form, more liberal form of this direction cosines is direction ratios. So what are these direction ratios? Your order triplet A, B, C is said to be direction ratios of a line if they are in proportion with direction cosines LMN. So here, if ABC are direction ratios, then the direction cosines can be calculated as A by root over A square B square C square, B by root over A square plus B square plus C square, C by root over A square plus B square plus C square. So if you know direction ratios, you can find out direction cosines. So here, every direction cosine is a direction ratio, but every direction converse is not true. Every direction ratio need not be direction cosines, provided if it is a plus a square plus b square plus c square is 1, then it will be direction cosine. So every line so now let us look into this. Suppose 1 by root 3 minus 1 by root 3 and plus 1 by root 3 are the DCs of a line. Then DRs can be 1 minus 1 1, 2 minus 2 2, 3 minus 3 3, okay, root 3 minus root 3 root 3. Like that you can have infinite direction ratios. Every line has two DCs but infinite direction ratios. Right, this is about direction cosines and direction ratios and their relation between them. Then comes plane. What do you mean by plane in space? So a plane is a flat surface. It is a collection of infinite points such that if you join any two points in the plane, you will get a line, and that every point in that line completely lies in the required region, in the considered region. Then this region can be called as a plane, or simply you can understand as a flat surface which is unbounded infinitely. Right. Now how to give the equation of a plane? So let's look into these forms one by one. Equation of a plane, we have many forms in 3D. Okay, like we have many forms of lines in 2D. So equation of a plane in normal form. So if you consider a plane, what are the things which are fixed for a line? What are the things which are unique for a line or for a plane? Means normal direction. Every plane will have a normal direction. So of course, like many planes may have same normal, but every plane will have only one normal. So this is normal direction. Suppose you choose a point P, so choose a point A. So only normal will not be sufficient to fix the plane. You need a point on the plane. Let us call it as a point position vector A bar. Then the locus point, suppose you pick P as R bar. Then the line joining AP is perpendicular to normal vector. So AP is perpendicular to N normal. So that means dot product is 0. So R bar, what is that one? R bar minus A bar dot N cap will be 0. That itself can also be written as R bar dot N bar equal to some constant A bar dot N bar. We'll let us call it as D. So this is called vector form of a equation of a plane. And the Cartesian form of equation of a plane, by choosing R bar equal to xi plus yj plus zk and substituting this, and the drs of the normal, suppose it is A, B, C, then the equation DC's are, then the equation would be ax plus by plus cz equal to D. So if LMN are the DC's, of the line, then that RHS, whatever you get D, that is the distance from origin. This is the equation of a plane in normal form. Next, equation of a plane in perpendicular to the given vector and also passing through the given point. So this is another form where, so here r bar ap dot n equal to 0. From that only you will be getting here. Suppose you have a plane, it is passing through a point x1, y1, z1 and perpendicular to the normal vector, drs of that normal vector. Every line has a direction, so it is a, b, c. Then a into x minus x1, b into y minus y1, c into x minus z1 will be 0. This is the Cartesian form of a equation of a plane. If you know normal drs and you know a point, you can find the equation of the plane in this way. Similarly, suppose you have a plane and you are given two lines which are parallel to the plane. Let us call them a bar and b bar, and this is the plane, and a plane is passing through some point a, some x1, y1, z1, or some, let's call this as a c, b bar and c bar are the lines, and a position vector of a is a bar. Now we want the equation of the plane. So if you want the equation of the plane, two things we need. One is a point, one is the normal. So what would be the normal direction which is perpendicular to both b and c? So b bar cross c bar. So normal direction is b cross c and the point on the plane is a bar. So a bar, so if you take a position vector p, pa is perpendicular to b bar cross c bar. So from this you will get r bar minus a bar, b bar and c bar are the cross product, the scalar triple product will be 0. That is box r bar minus a bar, b bar, c bar is 0. If you convert into Cartesian plane, what is that box a, b, c means? It's a determinant of a matrix, 3 by 3 matrix. What are the elements will be there? So first row elements will be x minus x1, y minus y1, z minus z1. And second row elements are drs of the first line. And the second one is the drs of the second line, which are parallel to the plane. When do you say that a line is parallel to a plane? Means if the line do not intersect the plane, okay, or the distance between the point, any point on the line to that plane is always the same, then we call it as a parallel to the plane. Or simply, if the line is normal to the, if a line is perpendicular to the normal to the plane, then also we can call it as a line is parallel to plane. Right, this is another form of it. Suppose if 3 points on the plane are given, only 3 points are in the plane are given. So what are the, finally what are the things required to construct an equation of a plane? We need 3 drs, 3 lines, because, okay, look at it. So suppose p is the locus point, a, b, c are the points given. You just construct 3 lines pa, pb, pc, and the drs of these 3 determinant equal to 0 will give you equation of the plane. Right. There is another form that is called intersect form of a plane. What is that intersect form of a plane? Means if a plane intersect x-axis, y-axis and z-axis at 3 points, if a plane intersect x-axis, y-axis, z-axis at 3 points, a, b and c, with coordinates a, 0, 0, 0, b, 0, 0, 0, c, then the equation of the plane can be taken as x by a plus y by b plus z by c equal to 1. Whenever, what is the general form of, now so far we have seen many, many forms of the plane, equation of the plane. So now every form, after you convert into simplified form, that will comes out to the form of ax plus by plus cz equal to d. This is the equation of the general form of the equation of the plane, or plus d equal to 0. So every form will be converted to this form finally. Okay, this is about a plane. Right. Next comes to equation of a line. So how do you describe a line in space? Suppose you have a straight line, and what are the things required to describe a line? Means definitely we need drs or dc's, and we need a point. If you know these two things, enough to describe a line or to construct a line. Suppose you take a locus point P, x, y, z, then that these two P A AP will be parallel to that DRs. So suppose the DRs of that line are A, B, C. Then this AP is parallel to AB, the DRs of that one, A bar, sorry, ABC. Why we are taking parallel means if two lines are parallel, they have it same DCs. Okay, if two lines are parallel, same like in 2D, slopes are equal. Here DCs are equal, but the DRs are proportional. That means if the DRs of the first line is A1, B1, C1, and the DRs of say L2 is A2, B2, C2, then that if they are parallel, we do take the proportional. A1 by A2 equal to B1 by B2 equal to C1 by C2 is the condition. If they are perpendicular, so dot product is 0. That is what A1 A2 plus B1 B2 plus C1 C2 equal to 0. Now here to construct the equation of a line, so take a PAP, DRs of AP and DRs of the line, that parallel means proportional. Proportional means x minus x1, y minus y1, z minus z1, and A, B, C are proportional. Proportional means they are equal. So this is the equation of a line. This is also called symmetric form of a line. So we have only one form of a line. We have many forms of plane, but we have only one form of line. So there is suppose if 2 points are given in a plane, in a line, say x1, y1, z1, x2, y2, z2, then the equation of the line can be written as x minus x1 by x2 minus x1, y minus y1 by z2 minus y2 minus y1, z minus z1 by z2 minus z1. This is the equation of a line. Right. Now we can talk about few points. Right. So vector form of equation of a line here is r bar equal to a bar plus dv bar, means passing through a bar parallel to b bar. So that is what. So when you write a line equation as x minus x1 by a, y minus y1 by b, the denominators represents the drs of the line, and this x1, y1, z1 is the point on the line. Right. Next, angle between two lines. Angle between two lines is the same as that angle between the lines parallel to those two passing through origin. So that is what angle between two vectors whose directions are b1 and b2. So b1 dot b2 by mod b1 mod b2 will be the angle between two lines. If you write it in Cartesian form, then cos theta equal to a1 a2 plus b1 b2 plus c1 c2 by, if you use the dot product of those two, a1 a2 b1 b2 c1 c2 by root over a modulus of a1 modulus of a2. So here if you convert it into direction cosines, then cos theta equal to L1 L2 plus L1 L2 plus L1 L2 modulus. So whenever they are perpendicular, so dot product is 0. So a1 a2 plus b1 b2 plus c1 c2 equal to 0. If they are parallel, so they are proportional. a1 by a2 equal to b1 by 2 equal to c1 by c2. Now angle between line and a plane. Suppose you have a plane and you have a line. Now they will intersect at some point P. Now if you want the coordinates of P, so here one more thing which is very 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 crucial, that general point on a line. Suppose if the given line is x minus x1 by a, y minus, let us take x minus 1 by 2, y minus 2 by 3, z minus 3 minus z by 1. Okay, it's given the equation of line. Then what are the drs of the line? 2, 3 minus 1, not plus 1, because it is 3 minus z is given. So this 3 minus z has to be converted to x minus 1 by 2, y minus 2 by 3, z minus 3 by minus 1, suppose you call this ratio as lambda, then xyz can be written as 2 lambda plus 1, 3 lambda plus 2, minus lambda plus 3. So this is what the general point on the line. It's every point on the line will be of this form. But for different values of lambda, you'll be getting different points. So take a general point on the line and substitute in the plane equation. Okay, plane equation, you will be getting the lambda value. Substitute that lambda value, you will get the coordinates of P. Okay. Now the angle between the line and plane means, suppose you take the normal to the plane. So if the angle between the line and plane is theta, then this will be 90 minus theta, and you can use that cos theta, cos of 90 minus theta. Okay, you can same angle between two lines, a bar not b bar by mod a mod b, you can use it. Okay, right. Now come to that application part. These are all descriptions about different things. Okay, in 3D zone. So coordinate system, direction, what are direction ratios, what are planes, what are lines. Now the questions will be asked like this. So here the questions will be maybe targeting the discussion between point and a plane, or point and a line, or line and a line, or line and a plane. So one by one let us discuss. What are the things they may talk about a point and a line? So there is a plane and a point. So they may talk about a distance between point to plane. Yes, the formula is modulus of ax1. The distance between those two is modulus of ax1 plus by1 plus cuz1 by root over plus minus d plus d by root over a square plus b square plus c square. What is that? Where equation of the plane is ax plus by plus cz plus d equal to 0, and the coordinates of the point is x1 y1 z1. So distance between point to plane, or they may ask distance between point and plane parallel to some other line. So parallel to that, they may ask the distance. So you parallel to this line, you know the drs of this line, you can construct that equation of this line so that you will get the point of contact, so point of intersection. Then you can find the distance between P and Q, you will be getting the length. Next, the other things they may discuss is that foot of perpendicular. The foot of perpendicular also same like in 2D, we have formula h minus x1 by a, k minus y. If the coordinates of foot of perpendicular is h, k, l. So h minus k x1 by a, k minus y1 by b, and l minus z1 by c equal to minus of ax1 plus by1 plus cz1 plus d by a square plus b square plus c square. Similarly, if you want image, you will get a minus 2 times. You will be taking minus 2 times of that. Same like in 2D. So here you will have third coordinate. So these are the things about point and plane. Next, point and line. So what are the things that can be discussed about a point and a line? You are given a point P, suppose x1, y1, z1, and you are given a line. X minus 1 by 2, y minus y plus 1 by 3, and z by 4. Then how to find out the perpendicular distance from point to line? So we take a general point on this one. The general point we may take it as equal to lambda, you take it. So 2 lambda plus 1, 3 lambda minus 1, and 4 lambda you can take it. And since PQ is perpendicular to, that line, so DRs are dot product is 0. So dot product you can take it equal to 0, so that you will get the value of lambda. Substitute that value of lambda here, you will get the coordinates of Q. Then find the distance PQ. This is one way you can do it. Okay, there is one more way also you can talk. So a point on the plane is 1 minus 1 0. That is some point. 1 minus 1 0 is some point on the line. You can, this distance. You can use cos theta. To get that. So you can use sin theta to get that length PQ. That is also another way we can do. Next, very important, line and line. So what are the different positions of two lines in space? So they may be parallel, they may be intersecting. If at all they are intersecting, they will intersect at one point. They may be coincident. And the fourth position is neither intersecting nor parallel. We call them skew lines. We call them skew lines, neither intersecting nor parallel. So whenever they are intersecting, they have a common point. When they are parallel, the distance between that perpendicular distance will be always same. But when they are skew lines, there exists a line perpendicular to both the lines and intersecting them at some points A and B. This AB is called the shortest distance between two lines L1 and L2. Okay, let's see that one also. So next, line and a plane. Line and plane we have discussed how to find the point of intersection and whether it is a parallel or perpendicular to the plane. Right. Let's look at the distance of a point from the plane. We have discussed modulus of this one. Shortest distance between two lines. How to calculate that one? If two lines are skew lines, okay, then there exists a line perpendicular to both. Let us call the point of intersection is AB, L1 and L2. Then the drs of this perpendicular line will be the normals, like drs dot cross product of these two lines, drs. So if the drs of the first line, if the drs of the first line is B1, dr of the second line is B2, then this will be B1 cross B2 will be the drs of the perpendicular line. Okay. So and suppose you choose a point, suppose A1 bar and A2 bar are the 2 points on the line L1 and L2 respectively. So it is A1 bar and it is A2 bar. So the projection of this line segment, okay, this line, because A1 bar and A2 bar are the 2 points, some random points, but this distance need not be same, shortest. So projection of this on that L1 on this perpendicular line on this perpendicular line, the projection is called will be called as the shortest distance between the two lines. So projection of a vector A bar on B bar means A bar dot B bar by mod B bar is the projection of A bar on B bar. So here we are taking the projection of here we are taking the projection of A and B on this perpendicular line. So let's call this as C. So AC on L1 cross L2. So that is what AC cross AC dot here B1 cross B2 modulus of B1 cross B2 will give you shortest distance between two lines. So when the shortest distance between two lines becomes 0, then the two lines will intersect. We call them coplanar. So that is why the condition for coplanarity is that this numerator becomes 0. Okay, so that numerator becomes 0 means determinant equal to 0. So x minus x1, y minus y1, z2 minus z1, a1 b1 c1. What is a1 b1 c1 a2 b2 c2? drs of the two lines. Right. Angle between two planes. So when you talk about two planes in space, so when two planes are intersecting, they may when two planes are intersecting, they will intersect along a line. They will intersect along a line. How to find this line equation? Here, first plane have some normal n1, second plane also have some normal n2, and that required line, the common line, will be perpendicular to n1 and perpendicular to L2 also. So this common line will be parallel to n1 cross n2. So cross product of the two drs will give you drs of the line. And this n1 dot here, to find the equation of this line, you choose some point, common point, and use that point and this dr, you can frame the equation of the common line. Next, So here family of planes, plane passing through intersection of two given planes. So passing through these two, you may have some other one more plane, not one more, many planes you may have it. And how to choose that equation of this plane means like a p1 plus lambda times p2 equal to 0, you can take it. So there will be infinite planes passing through containing the same line, okay, or passing through the intersection of these two planes, and that plane can be chosen as pi1 plus lambda pi2 equal to 0. So if that some extra information is given, using that you can find the lambda value and you can get it. So in short, these are all the main points related to 3D. So this half an hour will be sufficient to revise the complete chapter 3D, and you can go ahead with that PYQs. So PYQs are more important. Okay, so you can go ahead with the PYQs, right? So hope this information helps you, and all the best. Thank you.